Now that you completed exercise 2, guys, let's look at the answers and see what they should be. So question 1 says, consider the elements in period 3 of the periodic table. For each atom, write down the following: the number of valence electrons and the valency. Now, I just think it's easier if we know which ones are there. So I'm just going to start writing. So we've got sodium, then we've got magnesium. It goes over to aluminium. Then we've got silicon, phosphorus, sulfur, and chlorine and argon. So those are our elements we have. So the number of valence electrons, remember, it's 1 for sodium, it's 2 for magnesium. Then we jump to group 13, where we will have 3, 4, 5, 6, 7, 8 valence electrons. And the valency for group 1 to 4 will be 1, 2, 3, and 4, whilst for group 15 to 18, it would be 8 minus the group number. So 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1, and argon doesn't have a valency, it's a noble gas. Now, question 2 says, in which group of the periodic table will an atom have one pair of valence electrons? Now, one pair of valence electrons, remember, if you think of your electron configuration, they pair up, okay, in pairs before you start putting them in the p orbitals. Now, a pair of electrons is 2. A pair of valence electrons means that it will only have 2 electrons in the outermost energy level. So that will be group 2 of the periodic table. And then they say 3 pairs of valence electrons. 3 pairs of valence electrons are 6 valence electrons in total. So 6 valence electrons we will find in group 16. Yes, I know they don't necessarily compare up in group 16, so it can't be that answer. Hey, it should be group 17, because there we have 3 pairs of valence electrons, but one of them is unpaired. Okay, so be careful for that question because it catches you out. And then number C, 2 unpaired electrons. Now we need 2 electrons which are alone, which doesn't have a friend. Okay, so in this, if you think of your Lewis diagrams that we drew, okay, that we do find in group 16, because in group 16, if we take oxygen as an example, it would be 1s2, 2s2, 2p4. But how would that p orbital look? So the 2p orbital, you will have, there's your 3 orbitals, 1, 2, 3, 4. There's your 2 unpaired electrons. So that's why I say it's group 16. So this is oxygen as an example to explain that answer. Okay. Then question 3 says, draw Lewis diagrams for all the atoms in period 3. So to draw the Lewis diagrams for all the atoms in period 3, let's write them down again like we just did. So we had sodium, then it was magnesium, then it was aluminium, it was silicon, phosphorus, sulfur, chlorine, and argon. Okay, so sodium is in group 1, it only has 1 valence electron. Magnesium in group 2, it has 2 valence electrons. Aluminium in group 3, 3 valence electrons, or 13 specifically actually. Silicon group 14, 4 valence electrons. Phosphorus in group 15, 5 valence electrons. Sulfur in group 16, 6 valence electrons, so there's 4, 5, 6. Chlorine in group 17, 1, 2, 3, 4, 5, 6, 7. And argon in group 18, so therefore 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Now, they say explain the difference between the valence electrons and valency of an atom. Valence electrons are the number of electrons in the outer shell. Whilst our valency is the number of bonds an atom can have. And remember, the valency can refer to electrons transferred by gaining or losing them, or shared. So it's not just one thing. So it's the number of bonds an atom can make.